Thank you again, everybody, for joining us. As I was just saying, these discussions, I think, offer a huge amount to the people, obviously, that join in. But anybody that also comes back to the webinars, to the recordings, can get something out of it. It'd be great if you can share what you're learning with the wider community. If you're on Twitter or on Facebook or LinkedIn, anywhere that you connect with other professionals who you think would be interested in some of the things that come up through this discussion. I'll put some details on here for sort of hashtags that you might want to use, and you want to reference Redgate at All Things Oracle and at Grant Fritchey. Please do so. This webinar is brought to you by the Deployment Suite for Oracle, the SQL Developer Bundle, and Redgate software. As I've just introduced, and as Grant also introduced, the session is on statistics in Oracle and SQL Server, and it's a live discussion. This is the third discussion that we've done. I think the nice thing about these, and what is different to probably some of the other webinars that you log into and join, is the free-flowing nature of this conversation, of the conversation between Jonathan and Grant, so between an Oracle expert and a SQL Server expert. There are no slides. This is very much going to. Jonathan and Grant obviously had a chat beforehand. They know a structure to this conversation, but just so you're not confused, there will be no slides. This is a live discussion. So presenters today, Jonathan Lewis, who's coming from the Oracle side, a member of the OakTable Network and an Oracle ACE Director. Grant Fritchey, who's coming from the SQL Server side, a Microsoft SQL Server MVP. And as always, I'm James Mercer. I work for Redgate Software, and I'm the creator and editor of allthingsoracle.com. Everybody will be on mute for the duration of the session. I'm obviously talking now. If at any time the sound goes a bit strange, for those of you who have joined in the previous sessions, you'll know that the sound doesn't always go to plan. Hopefully we're nice and clear this week. If at any time you can't hear us, please first check your own audio settings and do let us know. We're going to try something a little bit different with this session in terms of the questions and answers, as you'll see when I go on to the agenda. We're not going to have a Q&A at the end. What Jonathan and Grant are going to try and do is answer questions as they go along. It's unlikely we'll be able to answer the questions exactly as you type them, but Jonathan and Grant will check the questions panel, have a look if there's any interesting questions that will expand on what they're talking about, maybe bring out some things that they haven't spoken about. I think it will work a lot better this way. I think sometimes what we've tried to do before is answer a load of questions at the end, some which have been answered at earlier parts, and some which don't really quite fit into the conversation. So we really want to try and keep this conversation flowing. So please do ask questions as we go along. Jonathan and Grant will try and answer them as they go along as well. We're going to start with a quick introduction to Redgate. I know Grant's told you a little bit about himself already, but there will be a chance for Jonathan and Grant just to explain exactly what their experience is, who they are, and what kind of things they get up to in their day job. Then we'll move on to the live discussion. There'll be some contact details for Jonathan, for Grant, and myself. And if you're interested in looking at the tooling that we have on the Oracle side of our business, please do hang around. There's going to be a live demonstration of Schema Compare for Oracle after this webinar. I'm sure most of you have heard about Redgate now, particularly if you're using our tooling, or maybe you go to allthingsoracle.com, or you use SimpleTalk, or you come to the webinars that I put on and that my colleagues put on. For those of you who don't know, Redgate's been around for about 13 years now. We've got quite a lot of tools, so we've got 45 tools on here. This is slightly out of date. We've released a couple more tools. We've got a couple of new tools in beta as well. Primarily, though, we produce tooling for database development, administration, and application development. The main technologies that we're involved in is Oracle, SQL Server, and .NET. We've got a nice little graphic here showing a world map of exactly where most of our customers work and live. This number here is growing all the time. It is well over 600,000 users rely on our tooling now. I think a nice graphic or a nice part that we've got at the bottom here is what our users say, and this is hugely important to Redgate. We work very hard to produce high quality tooling, but it doesn't stop there for us. We provide support throughout evaluation and integration of our tools, and things like these webinars, things like Simple Talk, SQL Server Central, all things oracle.com, all of these services we put on to help you guys learn and understand things about the technologies that you're working with, and ultimately we aim to help you both by providing tooling and providing education, and I hope everything that we're doing is helping you out. You can obviously find out more about Redgate software, our tools and our other community activities at redgate.com. Okay, so I'm just going to hand over to Jonathan now to tell you a little bit about himself before we kick off the main discussion.
Okay, thanks, James. Well, James has actually put up a slide there which probably summarizes just about everything I might want to say about myself. 25 years experience of using Oracle, that's about it really. I've never actually been employed by Oracle Corporation, and I've been a freelance, a self-employed specialist for most of that 25 years. So that's about it really, except of course I've written 3 books, contributed to 3 books. I advertise those on my blog, and I think, yes, the blog address is actually there. So that's enough from me, I think, to get us going. James, back to you.
Thanks, Jonathan. Jonathan will also be pleased to note that I have updated the experience, because it's slightly out of date on the last webinar.
Oh, right.
And I think, Grant, you've probably introduced yourself, but please do so again, for we've had quite a few people join since then.
Okay, sure. Sorry. Again, my name is Grant Fritchey. I'm SQL Server MVP. I've been working with SQL Server since version 6.0 back in '95, and that's it. I blog at scarydba.com, and you know, I work for Redgate Software, and I love saying that.
Thanks, Grant. Okay, so we're going to move on to the live discussion now, but before we do that, firstly, I just want to make sure that you're all still listening to us. I hope the introduction wasn't too long, but also I'm really interested to know how many people we have in the audience that use Oracle, how many use SQL Server, and how many people use both. So I'm going to bring up a poll and just give you a few minutes if you could just answer the question that pops up.
Well, that's fascinating results coming up there, James, and a remarkably good rate of response from the audience, I think.
Absolutely, that's what I was just looking at. So 30 seconds in and 80% of people have voted already. So I think that answers my first question, that everybody is definitely still listening to me, which is fantastic. And then that sets it up for the discussion. And it's also, I think, very interesting that nearly 50% of the audience, or virtually 50% of the audience, use both Oracle and SQL Server. So this seems to be a great session.
Yeah. Can the audience actually see these results, or do you have to do something special to show them to the audience? I see there's a question up asking for the results already.
Yep, the results will come up in a moment.
I see someone's just asked the question, how do you research material for your books, etc., related to Oracle? The answer is I do an awful lot of work on all sorts of different customer sites, and that reveals all sorts of interesting problems. And really, I just run Oracle and construct experiments and do lots of tests trying to pin down exactly what is happening.
Okay, I think I'll close the poll now. 88% of people have voted, which is absolutely fantastic. Now let's have a look at the results.
Interesting.
So we've got quite a big audience from the Oracle community, but I think the fascinating part there is the amount of people that use both Oracle and SQL Server. So I'm going to hide this here. If you access the recording, you'll be able to get these results again. But let's actually get down to the main reason you're here, which is to listen to Jonathan and Grant discuss statistics in Oracle and SQL Server. As I've mentioned, this is a live discussion. There will be no slides, but hopefully the content itself is all you'll need to learn more about statistics in Oracle and SQL Server. So over to Jonathan and over to Grant, and please do ask questions as we go along.
Okay, Grant, so would you like to kick off? I think we suggested as the opening comment that perhaps just a thumbnail sketch of why we want statistics, what we do with them, and so forth.
Sure, not a problem. Well, statistics in SQL Server are probably one of the most important drivers for ensuring that you've got a query that works well on your data. Basically, the statistics are a mathematical representation of your data. They show a distribution of the data as well as the selectivity or how particularly unique that data is. These are created automatically on indexes whenever you create an index, assuming you have the default values set when you are running SQL Server. They are created automatically on any column that you reference as part of a where clause or a join clause or some of the other filtering clauses on data that will create statistics on those columns if they're not already part of an index. And also statistics are automatically maintained within SQL Server, assuming you've got the default value set. So as your data changes, the amount of data is inserted, deleted, updated, that will fire off a change in statistics. And the statistics are absolutely the primary driver for the query optimizer, and it's how the query optimizer decides if an index is useful, whether or not it can do a seek versus a scan. All kinds of information like that is all driven out of the statistics. They are stored in three basic sets of data. One is the header, which is just some descriptive information. Second is the density, showing the actual selectivity, as we said before. And then third is what's called a histogram, which is the data distribution of the first key, the leading edge key of the set of statistics that we're talking about. And that shows across 200 buckets the data distribution, where you could find a particular value if you were looking for it. In a nutshell, that's what statistics are in SQL Server. Now, having said that, the devil's in the details because things get weird very quickly with statistics. I think that's at least a decent overview. How about you, Jonathan?
Yeah, well, I think what you've said more or less covers the same sort of picture for Oracle. And there's a couple of variations. I tend to say to people, well, the key thing that the optimizer needs to know or needs to work out is how much data are you going to acquire and where is that data. So obviously, as you say, things like the density and distribution give the optimizer ideas about how much data you're likely to get on a where clause and whether it's going to be a good idea or not to use a particular index. So the same sort of principles apply. I did notice there was one thing you didn't mention in the description of SQL Server statistics, which Oracle does, which is actually this business of where is the data. It's all very well to say this particular predicate will give me an estimated 100 rows, but from Oracle's perspective, there's a big difference between 100 rows which are all in the same 2 or 3 blocks and 100 rows which are scattered across 100 different blocks. So when looking at the stats for an index, Oracle has a measure, it's called the clustering factor, a measure which tells it if I think you'd say seek, is that right, when you're using an index as a high precision mechanism. Right. If I use this index to identify rows in the tables, as I walk through the index, how much jumping around do I do in the table? So it's a measure of how scattered the data is, which Oracle considers to be an important measure of how efficient or how effective that index could be.
Now that is interesting. We have that same data available to us through a different, there's a different mechanism for looking at it. But to my knowledge, that is not in any way taken into account by the optimizer. It more or less doesn't care where the data is stored, which can lead to some pretty poor performance if you've got, you know, as you put it, the data is scattered all over the place.
Yeah. Yes, that's interesting. I mean, the clustering factor is hugely important in Oracle. Nevertheless, it's the way Oracle actually generates this figure can be very, very misleading. And of course, any statistics which are misleading can result in very bad plans. And Oracle's basic principle is to say, it looks as if I will visit 100 different blocks. And the optimizer then says, if I have to visit 100 different blocks, that's potentially 100 different physical I/O requests I have to make. So it almost turns the location into a count of physical I/Os. And the problem people often have in Oracle with statistics is that as the DBA, you can see that you've got a tiny bit of scatter, and the data you're interested in is in a few blocks which are likely to be in memory because they're you know, perhaps yesterday's orders or orders placed in the last week, which tend to be very, very well cached. But Oracle will often see a little bit of scatter and visualize it or store it statistically as a great deal of scatter, and then assume that none of it is cached. So it's a huge benefit in terms of better information, but there is a downside to it that Oracle will overestimate the scattering effect and the impact that has on I/O. And sometimes you can say, well, I know I've got an index which is very good because it's very precise, it tells me exactly what I want and I don't waste any work if I use it. But Oracle thinks it's quite bad because Oracle thinks the data I'm picking up is physically very badly scattered across the disk.
Huh, that's interesting. Well, it actually goes back to a question Brian asked. How reliable are auto statistics in SQL Server, and should you run stats manually, and how often? Which is a very loaded question, Brian. But it's interesting because SQL Server doesn't take into account the storage. It's only going to look at how accurate that particular set of statistics are. It kind of doesn't care whether or not they're distributed, which for good or for ill, as you put it. To answer Brian's question, how reliable are statistics, honestly, it depends on whether or not they were sampled or scanned. When you create an index, it does a full scan of the data and will then use that full scan of the data to create the statistics. In general, the automatic creation of other statistics and certainly the automatic update of statistics are sampled, meaning it looks at a random sampling of the data and makes up statistics that way. So when the statistics are scanned, they are fairly accurate. When they are sampled, they are not. Now, as to how often you have to run the updates, that depends. And I don't want to get into that for the moment because Jonathan could probably talk about how accurate statistics are in Oracle real quick.
Yes, I mean, there is an interesting difference between SQL Server and Oracle in that Oracle doesn't collect statistics automatically, or at least depending on the meaning of the word automatic, it doesn't collect them automatically. As the data changes, Oracle is recording various bits of information, but particularly the number of inserts, updates, and deletes on a table, and it will actually have a figure which it estimates as what it calls the staleness of a table, but that will not trigger any sort of automatic job to improve or recollect the stats on the objects. And there's one special case: if you do create an index or rebuild an index, since about Oracle 10, that automatically creates the stats on the index. But this staleness factor can come into play with a job which by default happens to be installed to run basically overnight for potentially a few hours, where Oracle says, I will examine the staleness. There's a call to this package called dbms stats. Any table which is sufficiently stale, I will now gather stats on. But that's not quite what you, I think, in SQL Server call automatic. And in principle, of course, the DBA could decide that they do not want to run that job, and they will run all sorts of separate and independent calls to other specific procedures within the DBMS stats package as and when they want.
Right.
So yes, part of the DBMS stats package then allows you to say, for this table, take a 1% sample. For that table, take a 10% sample. For this table, collect stats on the indexes as well as the table itself. For that table, collect only the indexes on the table. Oh, and by the way, these 3 columns should have histograms generated, but the rest of them don't need histograms. So there's a great deal of potential for very fine control about the statistics you collect.
Not on the SQL Server side.
Yeah.
The granularity is pretty much scanned or full. Those are your choices, and that's pretty much it. Now, we do have the built-in automatic procedure that a lot of people use. I'm sure several people out there have heard of SP Update Stats, which is runs the statistics update, and it does also look at a staleness measure, but it is a really bad staleness measure. What it looks for is the row modifier counter on the tables, which is great, and it looks for any value that is greater than 0, meaning if one row has been updated, SQL Server will say that those statistics are stale if you run that query, and it will run those updates against that data. And if anyone's interested, you can verify that because that procedure is not encrypted. You can open it up and look at it, and it shows exactly how it works.
Yeah. Interesting. Yeah. Yes, I've just noticed there's a question, actually quite an important question, perhaps as far as Oracle is concerned, which relates to, well, does every single column in your table have stats? And the answer to that is, well, yes, you could. I mean, by default, if you just say, here's a table, collect stats, you get statistics on every single column. And perhaps in the SQL Server world, you might ask, well, why? I mean, you mentioned earlier on, Grant, I think, that SQL Server automatically collects stats on indexes and on columns that appear in join clauses and where clauses. Well, in Oracle, we do collect stats on every single column by default. And of course, the argument why this is necessary is that not only do you need to know how to find data and what the best way of finding that data is, which is why you'd want the where clause stats and all the rest of it, but you might decide that you want to do a hash join or a merge join. And when you do that, the actual volume, in other words, the length of the average column, the average length of a column that you've got in your select list actually makes a difference to the amount of work that you have to do and perhaps the amount of data that has to spill to disk if you're doing a very large sort in order to do a merge join. Right. So for merges and hashes, it is a very good thing to have at least some statistics about the actual columns themselves. And key to that, the non-join type statistics, is really the number of rows in which a column is null and the average row length, the average column length for each column. But we do actually also collect the number of distinct values as well.
Now, somebody asked a really particular question, and since I was just dealing with this last week, I do want to answer it. They asked how we maintain statistics on partition tables, particularly partition statistics and global table statistics. And that's a fun one. That was, I'm going to pronounce your name wrong, so I apologize, Carol. And if I got it wrong, I'm sorry. That's a fun one because currently, by default, if no other action's taken, SQL Server will only maintain a universal global set of table statistics. You can create manually a set of partition statistics, basically filtered statistics on each partition. And I strongly recommend you do that, but it's something that you will have to do manually. SQL Server won't do it for you. So I just wanted to bring that one in because I realize it's kind of a jump from what you were talking about, but I've just been working with that last week, so I was kind of excited to see the question come by.
Right, yes. Well, I mean, partition, I would have said that one could easily spend a completely different webinar talking about partitioning because there are so many interesting problems that partitioning introduces, and certainly with Oracle, the whole problem of dealing with partition statistics is a pretty big one, because you could imagine, someone says, well, I've partitioned this table because it's got 3 billion rows in it, and when Oracle says, okay, I'm going to take a 1% sample of your data and I'm going to do this massive sort and aggregation in order to work out the number of distinct values in each column, that's an absolute killer. So you've partitioned it into, say, 1,000 partitions. Well, potentially you need 1,000 sets of statistics plus 1,001 set because you want the table level stats. Now, I don't know how the SQL Server optimizer works. Oh, actually, we ought to postpone this till partitioning time, maybe, till we have a webinar on partitions. But, actually choosing when to create statistics and how you get from partition level stats. Oracle, you would tend to create partition level stats by default and somehow aggregate them up into table level stats, and Oracle keeps refining the processes, and people write manual code in order to do clever tricks to minimize the work on collecting stats of very large tables. But it is a fascinating problem.
Yeah, it's a similar issue on SQL Server, but we don't have quite as many knobs to tweak as you guys do. And yeah, we should probably put this one off for another, because there's a lot more to talk about there. Now, here's something someone asks that I don't have a good answer for, and I'm sure you will. What is the importance of server stats? Now, he says CPU memory, and how often should server stats be run in Oracle, and does SQL Server also collect server stats? And I suspect that we're conflating performance metrics with statistics. But since Oracle is very different, I thought I should ask that question.
Well, Oracle, it shouldn't be server stats. I'm sorry, I've missed the question. It must have rolled up while I was talking. You don't have server stats in Oracle. You have this thing called system stats, and it is very much like stats on objects. It is a statistical description of your actual equipment, and basically what you capture is the CPU speed in terms of millions of Oracle operations per second, the average time to do a single block disk read, the average time to do a multi-block disk read, and the average number of blocks that came up in a multi-block disk read. And essentially Oracle is trying to say, I know how fast your machine can run. And then of course it can come up with things like, I've got to pick up 100 different rows from this table, but they're in 100 different blocks, which means I'll spend this much time if I do 100 single separate block reads, or if I go through your table, and I reckon I'm going to do this at 17 blocks at a time, if I divide the number of blocks in your table by 17 and check how much time it would take to do that many reads, which is quicker, the 100 single block reads or the X multi-block reads? So there is actually a statistical piece of information that we can collect. And I have to say what I tend to direct to people is to say, well, Oracle has some defaults for those, and just don't muck about with them, because although they're dated about 1970s in terms of realistic numbers, the basic ratio is that multi-block reads tend to be somewhat slower than single block reads, and in many, many, many cases that is sufficient to bias Oracle just a little bit towards using indexes when it's quite appropriate. But we do have this thing which says, can we tell the database how fast the hardware can operate?
Interesting.
Yeah.
I kind of wish we had these toys. No, these are fun knobs. I wish we had them.
Yeah, I think that's quite a helpful one. But even though I say to people, don't fiddle with it, it is quite a helpful one. Yeah, and I mean, another strategy I say to people is, well, go to your manufacturer's specification for your disk drives or your SAN, and if they say my seek time is 3 milliseconds and my transfer rate is 128K per millisecond, you can actually feed those into system stats, and telling Oracle how fast the disks can work is quite helpful. But it's nice either to use defaults or to be truthful.
Cool.
But can I come back to a comment you made, because there's this great feature in SQL Server which I'd really love to see in Oracle. You said something about filtered statistics. Now, in Oracle, one of the biggest problems with the optimizer is that you cannot collect enough statistics. And what you often need is sort of correlated statistics, if you like. If I run in a query which says, of the orders which are currently active orders that have not yet been delivered, tell me about the orders which are for product X. Now, of course, what I'd like to be able to say is I need statistics only about orders where the status is not C. Now,
Right.
as far as I understand, you can actually say to SQL Server, collect statistics on this table where column X does not equal to C.
Absolutely, we can,
Yeah.
and it makes a big difference. The optimizer can take advantage of those stats, and it will rearrange the way it puts the query together based on that information.
Yeah.
You can also do the same thing with indexes, of course. You can create a filtered index, and then the statistics on that index are based on that same filter.
Yeah. I mean,
But,
to me, yeah. That is a truly terrific little feature, which I think would answer an awful lot of performance problems that people have, because you so often have queries which are, well, you know, there are 15 different values that this flag column can have, but I keep running queries about one particular type,
Right.
and the optimizer doesn't have quite enough information to do the sensible thing.
Yeah, exactly. That's interesting. Now, one person asked the question, this is pretty common in SQL Server, I bet you Oracle doesn't run into this, so I'm going to answer this one real quick. They asked the question, I notice a few DBAs run both jobs, reindex followed by update stats, and they ask if they need to update stats after reindexing. I suspect Oracle doesn't run into this, but this one's a common one in SQL Server. There's two ways that we can defrag our indexes, which would be to increase the clustering factor, right? I think I got that right, in Oracle. And that's
decrease the clustering
decrease,
factor.
yeah, sorry, decrease.
Sorry, and that doesn't. When you rebuild an index in Oracle, it doesn't change the clustering factor at all.
Oh, okay.
Right.
Well, we've got two ways of doing the rebuild. One is a complete rebuild, which does defrag the index, and the other one is simply it's a logical defrag. It's not the same as the physical defrag, and one of those, the full complete rebuild, updates the stats doing a full scan. The other one doesn't affect the statistics in any way. Now, what's funny is people will rebuild their indexes completely, and then run sp_update stats, which does a sampled update on statistics. So what they're doing then is taking a very accurate set of statistics and turning it into a sampled set of statistics. So it's a crazy thing that people do in SQL Server, but it's something they should stop doing. If you're going to do an index rebuild, stop there, don't update the statistics on that index. If you're doing an index reorg, you could update the stats.
Yeah. Yes, I think an interesting feature on that, I think also there was a question about this earlier on, is that SQL Server, of course, follows a strong pattern of building clustered tables, which means in fact your data is more or less in the index, whereas
Right.
we had this discussion 3 months ago. Oracle uses heap tables and then creates B-tree indexes on heap tables. Now, rebuilding an index in SQL Server, if it's the clustered index, of course, puts all the data in the right order, and if you had a clustering factor, that would minimize your clustering factor, and you know, that's why Oracle needs that particular measure, because it doesn't have its data. In general, it doesn't have its table data as part of the index, so where is the data scattered across the heap matters a huge amount to Oracle. And I do wonder if some of the differences in the statistics that are available and the things that people do about statistics are actually controlled in a fairly big way by this sort of very strong divergence between clustered indexes to hold the data and heap tables to hold the data.
I suspect that must be something of it. I mean, it strikes me that SQL Server does a lot of its studying for us and gives us few knobs to tweak, whereas you guys have many more manual jobs, but you also get a lot more knobs to tweak. So I suspect it's the automation that makes us do some of the things the way we do them. But boy, people can make some serious mistakes with statistics. Now here's a fun question, because I'd love to hear your answer to this. How do you get the statistics to the developers to help them develop more efficient, effective queries?
Right. Now that's a very good question, because I think, alas, the answer is, in general, we don't.
Yeah.
I think this is one of the big areas. perhaps there's a bit too much finger pointing on it, but I think this is one of the big areas where developments fall down. And when I say developments, I don't mean the developers, I mean the whole project type of thing. Because designing the database, one of the things you ought to know is, well, how many orders does the average customer place in a month? How many products does a customer order when they place an order? How many days are there between order being placed and delivery taking? You know, all these statistical things about the potential volume and pattern of the data and the physical distribution, this clustering type feature of the data. That type of information, I think, is hugely important when you come to designing a physical database layout, and also when you come to designing your choice of indexes and the way you write your SQL.
Yeah.
And very often at the development end, the figures are very, very vague. They haven't really been analyzed. They haven't been really researched, and sometimes it's impossible to find them. From the database end, from the DBA type of things, where the DBA could actually run lots of queries and say, well, yes, over the last year, an order has averaged 6 rows. Worst case is 27 rows per order lines, I mean, and 80% of the orders are for a single order line. And that type of information could be hugely helpful if fed back to the developers. But unfortunately, that flow of information in both directions simply doesn't seem to happen very often.
Yeah, I agree. I agree 100%. Perry, excellent question. And then just to add to that one bit, the interesting thing is that I don't think that the database developers and DBAs do a good job of explaining to the application and T-SQL developers just how important the statistics are. Just fundamentally, I think that's a missing bit. You know, just again based on had a whole series of conversations last week about statistics. So
I'm just going to interrupt you.
Not even related to our conversation.
I'm just going to interrupt you both there because
Sure.
I've noticed there's quite a lot of questions that have been asked. So I'm actually going to bring up another poll, just give you both a chance to catch your breath a little bit and have a look down the questions that have been answered and see if there's any in there that can sort of take the conversation further, or maybe even tie up a few of the bits that you've been talking about. So I'm just going to launch another poll. For this poll, I'm really interested to know where people actually go to access learning resources. So which of the following, please select as many as you can. Which websites do you visit regularly to access learning resources? Again, I'll just give you a couple of minutes.
Typed an answer there.
So I've got a very good comment here, actually, about there should be an other choice, and there should also be choices like Google or MSDN and even OTN forums and stuff like that. Unfortunately,
or even jonathanlewis.wordpress.com.
Jonathan Lewis,
Or
exactly.
Scary DBA.
Absolutely.
There you go.
There could be
calls Google is Junior DBA. So
there could be a huge number of answers. Unfortunately, I was restricted to 5, so I was sort of interested in some of the websites that Redgate manages, whether people use them, and kind of comparing that against YouTube. I was kind of guessing that everybody probably would use Google. I thought that would end up with quite a lot of responses anyway. It certainly seems to be the first place that most people search, first place I go if I'm looking for something. Okay, so 70% of people have voted. Maybe the 30% of people that haven't voted do use things like OTN and Google. And actually, we've just got a comment here from Sean, thank you, about most people here, probably from the Oracle community, are going to visit OTN regularly and Google regularly. But thank you to everybody that's voted. I'm just going to close that poll now, bring the results up on screen, and then hand back over to Jonathan Grant. Hopefully you've had a chance to scan through the questions, and we'll get the discussion back.
Go ahead, Jonathan.
Yeah, sure. Interestingly, we've got a couple of comments here about index rebuilds and the effects on statistics. We've got a couple of comments about the automatic recalculation overnight. It is very difficult dealing with, well, index rebuilds in Oracle, of course, are very rarely needed. I mean, the reason for rebuilding or reorging indexes in SQL Server, I guess, comes back to pretty much this clustered indexes approach. Much less important in Oracle, where the data that you're really interested in is in a heap, and the indexes are the things you use to get at it. So almost always a small percentage of the work you ever do is in the index, and therefore it matters much less that the index might be running a little less efficiently than a perfectly rebuilt index. And rebuilding an index, for example, doesn't change the clustering factor because it's all about where the data is in the table. But the business of collecting stats, how often should you do it, and is this semi-automatic, this scheduled job which collects stats every night if you let it, should you do it, and what's the effect of that? And it does depend a great deal, I think, on how big your database is and how big your hardware is and how busy your application is. Because if you have a very large set of data, well, this automatic staleness will mean that the really big tables will not have their stats collected very often because it will take a long time for 10%, and that's the magic number, by the way, 10% of the data to have changed. I should say that Oracle 11 allows you to change that staleness percentage on a table-by-table basis if you want to, but historically it was just fixed 10%. So big databases, you get no collection for a long time, then bang, one night you'd suddenly find that your machine was spending 3 hours hammering the disks to death because it was regenerating stats on some absolutely enormous table. At the opposite extreme, a relatively small system, you might end up collecting stats extremely regularly on almost everything and hardly ever notice it at all. So when people say, well, what's the impact of this regular job, there is no one answer which makes good sense.
Right.
And the thing I tend to say to people is, well, if you've got the resources to do it, there's probably no harm in collecting stats every single night.
Yes.
However, it is a point of instability. There is no good solution. Collecting stats every single night means the stats have changed every single night, and you've already mentioned the problem of a full scan or a sample scan, Grant.
Right.
If your collection is based on samples, the actual data sampled every night could be slightly different, and a small change in luck in your sample could occasionally cause a massive change in performance the following day. So nothing easy to do, except try and discover something that's as simple as possible that works really well for almost all your data, and then put your finger very carefully on the few special cases where you have to do something very special.
Yep, it's the same, exactly the same with SQL Server, although the magic number is 20%, not 10%.
Yeah.
And we do have, as of SQL Server 2008 SP1, we have the ability to set a trace flag, which makes it a dynamic number, so that the larger the data set gets, the more frequent the updates are. So you're not, waiting for that giant single update. You'll get more frequent updates. Although, as you put it, that can lead to other issues just as easily. So there's no good answer. I've got one I got one of the questions here that I wanted to ask you, Jonathan, because I think it's really interesting. We have a problem in SQL Server called bad parameter sniffing, and it frequently comes down to statistics. Either your statistics are stale, or your data is skewed in such a way that your statistics don't accurately represent some small data sets, or your statistics are so skewed they don't accurately represent any data set. And the question was, does Oracle have the same kind of issue?
Well, the answer is inevitably yes. I mean, the technologies are broadly similar, so the problems are likely to be broadly similar. The technical term we'd use in Oracle rather than parameter sniffing is bind variable peaking. Right? You write your code with a placeholder, and then the optimizer will, the first time you send the statement in, say, oh, I can see a placeholder, what's the actual value? I will optimize for that value. Right. And you can imagine, coming back to my example of orders which are completed, if someone sends in a query which says, select something about orders where the status flag equals placeholder, parameter, bind variable, right? Well, the optimizer will look at the specific value the first time around and produce a plan, and if it's your placeholder says completed, Oracle will say, oh, that's 99.37% of your entire data set. That's a number to bring in as part of the selectivity. Well, yes, this is a brute force type query. And then the very next second, someone comes in and says, tell me about orders where the status is, and the bind variable says outstanding for a long time, and there's 10 orders in the entire system. Oracle will reuse the same execution plan. Right? So it's not so much stale statistics that tend to cause these bind variable peaking problems. It is literally the fact that some columns are skewed, and if you use what do you call them, parameters, bind variables for these things, then you have the potential for the first person to run the query gets a good plan, everyone else might get a bad plan for the values they're particularly interested in.
Right.
Yeah.
Yeah.
Now,
of course,
yeah, I mean, this is where the histograms come into play, of course. If you have histograms on your data, Oracle can see that, yes, 95% of your rows say C, 0.01% of it say X. If you haven't collected histograms, Oracle will only say, well, there's 110 distinct values, so when you say column equals constant, it's just 1/110th of the data. So everyone gets the same plan all the time, and everyone is unhappy instead of only 1% of you being unhappy. It's, yeah, histograms tell Oracle, well, and SQL Server as well, a lot more about the data. But one of the problems then is, if you're using histograms, if you really want to take advantage of histograms, you cannot write your SQL so that, or you have to carefully rethink how you present your SQL so that you don't run into this bind variable peaking problem. And your developer code has to use one of 3 or 4 mechanisms to cooperate with the database server.
Well, the question came from, I'm not even going to attempt to pronounce this name, Mr. Jensen. They see the bind parameter problem with histograms. Do they recommend, he says, I recommend not using histogram until otherwise proved. Do you agree? Now, at SQL Server, of course, that's not an option. We're using histograms, period.
Yeah. Well, my general view is really, it comes back to keep it very simple and then fix the things that really need fixing. I tend to advise people to disable histogram collection until they recognize the particular queries and the particular columns that need histograms. And then, once they can identify that sort of query, they may have to say the developers have to change the code because otherwise we'll run into the bind variable peaking problem. And also, rather than letting Oracle simply sample or even examine 100% of the data to construct the histogram for itself, I will write a piece of PL SQL which will construct a model histogram which always gives the optimizer roughly the right idea.
Interesting.
And fortunately Oracle allows you to do that, and sometimes it's absolutely necessary. You see, I mean, this comment about when do you collect statistics and how often and all the rest of it, Oracle tends to do this between 10 o'clock at night and 6 o'clock in the morning.
Right.
Okay. Well, imagine you've got some sort of workflow processing system, and at the start of the day, people start generating data where the status flag is A, and as you work through the day, the status flag on some piece of work goes from A to B to C to Q to S to X and then goes blank.
Right.
Well, if you collect a histogram at some time between 10 o'clock at night and 6 o'clock in the morning, perhaps all the interesting values that people need to know about during the day have been processed through and simply don't exist at all. So you could get a perfect histogram which tells Oracle exactly what the data looks like at 10 o'clock at night, and that's got nothing to do with what the users believe their data looks like at 9 o'clock in the morning.
Right.
So
it's fun.
You have to create a histogram which describes the data that the users want Oracle to believe is there.
Right.
Right. It's a tricky subject. I have to say, by the way, I mean, there'll be Oracle people sitting out there in the audience saying, yes, but what about? And one of the what abouts will be adaptive cursor sharing. Right. Oracle 11 introduced this feature where Oracle would say, do you know, I've just peeked at a bind variable and there's a histogram on this bind variable, or there's a couple of other conditions. So maybe if someone runs this query with a different set of input values, I ought to use a different plan. So having created a plan, there are cases where Oracle 11 will watch the execution of that plan and say, at this step I predicted 100 rows, oh heck, there's 3,500 rows. That wasn't a good idea. And it will then sort of mark this statement as being sensitive to the input values. It will be called bind sensitive. And then it will start re-optimizing that statement. And when it sees values similar to the ones it's used before, it will use plans it created before. When it sees values which are highly suspect and look very, very different, it will say, well, perhaps I should re-optimize this one and come up with a different plan. So you can end up with a single statement which has several different plans in memory, and the optimizer will say, new values incoming, it falls into this range, let's use plan B.
Right.
It's still technology which is a little fragile, it's still a little bit under development, but it's trying to address exactly your parameter sniffing problem.
Right. Yeah, in parameter sniffing on SQL Server, of course, we use methods to either direct the optimizer to use a particular value against the histogram, or to have it sample or average the values in the histogram. The one thing that was mentioned by someone was using local variables as a mechanism. That's an older method, but it worked, from 2000. But it works really well to give you a sampled metric. Another question that came in: our data is not frequently updated. I presume I do need to update statistics and run explain plans, Oracle obviously. Certainly whenever we significantly update the database, whenever we change the characteristics of the database. And the question is for a large data set, blah, blah, or for a not large data set, how big a deal is it that the explains are showing table scans instead of index scans? I'll toss this one over to you, but it seemed applicable to both, so I thought I'd get a little bit out of it first. From a SQL Server standpoint, I'd be very concerned that I was seeing lots of table scans. It's indicative that you don't have clustered indexes, one. Two, even with small, 2 million rows is not big. With small data sets, you should be able to get selectivity on your indexes, and with an appropriate filter, see seeks. It's just pretty normal. And statistics do need to get updated as the data changes. So it's something that you would need to stay on top of. You couldn't just ignore it. I'm sorry. Go ahead, Jonathan.
Yes, I mean there are so many variations around the edges, though, when you start talking about table scans and so forth. And in principle, table scans could be the most effective thing to do, and certainly if we're getting into the sort of DSS side of things, or reports on an overnight reports on an OLTP system, there's no big deal often with seeing table scans. Generally with OLTP, though, we would expect to see most data access to be index driven. I tell you what, even the word small is actually very difficult to define. You just said, I think, did you say 2 million rows is not big, or did you say 2 million rows is quite small?
I might say small, but I wouldn't call it
some
big.
people you'll see, I mean, some people you'll see, OTN, the Oracle TechNet. Occasionally, people come up with, I've got this really big table. It's got nearly 600,000 rows in it.
Right.
And other people say, that table's only got 25 million rows in it. That's small. So there's it's always very difficult when people say big and small, because they have such preconceptions about what they mean.
True.
Yeah. No, I always take the thought that you need to know roughly how much data you've got, how much data you're after, and what are your possible access paths to get that data, and which does the least amount of work. And frankly, in Oracle, you could find that the most efficient way to find one row in a table which contains just one row is to create an index on it. Right? Whereas, you'd have to think normally that a one-row table must be a small table, but it can even be efficient to index a single row for various odd reasons. Of course, one would perhaps put it into an index-organized table, the sort of clustered index thing.
Well, based on, I think we're almost out of time. Based on the questions, we should do this session like every other week. Because we didn't answer, we didn't answer half of what's been asked here.
Yeah, it is just a little difficult, of course, because you could spend a half hour on various of these questions. I see there's one question here talking about index column combination. Sorry, not index, column combinations. You've got something rather nice, I think, in SQL Server, that when you collect stats on an index, am I right in thinking that Oracle will collect stats on just the first column, then the first two columns, then the first three columns, and then the first four columns, all the way through to the full length of the index?
Right. Yeah, we do and we don't. The density is exactly as you described, but the histogram is only on the first column and nothing else.
Okay, but even so, I mean, the density is a hugely useful thing if you look at all those possible column combinations, because you often see queries which say, I've got this 5-column index, but my join is only on the first 3 columns. But in Oracle, you only collect stats on the whole set of the combination, the complete length of the index, and of course, for individual columns, you've already got the individual column stats. So if you have a join which says 3 columns out of 5, Oracle just says, well, I haven't got a 3-column combination. I'll take the 3 separate densities, you'd say, and I will multiply those together to get the final density. But if that's less than the total index density, I'll use the index density. So there's faking going on there. So that's a lovely feature, I think, in SQL Server. But there was this question about extended stats. Because Oracle 11 came in and said you can collect statistics by specifying all sorts of virtual columns, but one of the options is to say on column combinations. So you can create extended stats saying, I want stats on the combinations of the first 2 columns in the index, stats on the combination of the first 3 columns in the index, and so on. Right? And that can be very helpful. And I mentioned your filter statistics in SQL Server. You can get close to that sort of thing for very special cases in Oracle, because you can collect stats on something which says, well, collect a combination of the status flag and I don't know, the value. You can combine columns. It doesn't work quite as well as filter stats, but it can help a little bit.
Right.
So yeah, there's all sorts of things one could say about statistics and how Oracle uses them and how there are the differences and so forth.
Oh yeah, well we haven't even covered temporary tables. We haven't covered, oh my gosh.
Yeah, yes. Well, I have to say I read the article which you published on All Things Oracle just a couple of days ago, and I thought, well, we could just sit and talk through that article and spend a couple of hours just talking about the ramifications of just the few points you picked up there.
Right.
Yeah. Now, I think if someone wanted a thumbnail sketch of what to do about statistics in Oracle, the answer would be, I think, as I said before, find something very simple to do, which is not going to overload your machine. You want to avoid using up too many resources, so find something very simple that's good enough almost always, and then look very, very carefully for the special cases. And then you might have to do something a little subtle and complicated in order to be able to get good statistics. And the bottom line is you can always invent statistics in Oracle and say to Oracle, treat this table or this index or this column as if the data looks like this. And that's a tremendously powerful thing to be able to do.
Yeah, I kind of wish we had that one. SQL Server, the rules are basically the same. Do as little as possible, keep it as simple as possible until you identify that you're in a situation where you've got to do something different. And as far as it goes, I would update statistics as much as you can in SQL Server, as frequently as possible, with the full knowledge that once you get into big data sets, and yeah, you'll have to define that, you're going to see the impact because it can take a long time to do. I was watching one occur last week on a fairly large machine, and it took 45 minutes for one table, one set of statistics. So
yeah.
it can be extremely painful process. So just be careful when you get into the edge cases.
Thank you both.
Don't mix your index maintenance and stats maintenance together. If you're going to update stats, then do index maintenance. There we go. Sorry, I'll shut up now.
Thank you both so much. I think the little summaries at the end were great, and similarly we've had some really nice feedback that's come in to say so as well. As Jonathan and Grant both said, I think this topic is something that they could probably talk on for hours, if not days. Sorry. So, sorry if we were unable to answer the questions that you've typed into the question panel. I hope, though, that the questions that we did answer, and as the conversation, the discussion went on, it did go some way to help you and maybe answer a few points of the questions if they didn't actually specifically answer your questions. I'm gonna, obviously I have a record of all the questions that were asked. I'll share this with Jonathan and Grant, and we'll see if we can put together some answers for some of the ones that that are kind of particularly important and sort of tips and advice, and we'll try and share some of these answers on allthingsoracle.com where we'll publish this video.
Can we save the entire list of questions?
Absolutely, yes.
Oh, cool.
So I'll share that with yourself and Jonathan after the session.
Thank you.
Yeah, I'll try and run through that list if you do, and give brief answers to as many questions as I can.
I was going to say there's several good blog posts in there, so.
Well, yes. So luckily, some of the answers will be yes. I've written an article about that on my blog.
Fantastic.
Yeah.
And that's exactly the kind of thing. So I've just put contact details up for Jonathan, for Grant, and myself. Please check out Jonathan's blog, jonathanlewis.wordpress.com. There's a huge amount of information there, obviously all Oracle related. Grant Fritchey's blog, scarydba.com. Similarly, a huge amount of information on Grant's blog. Fair to say, Grant, that it's all going to be SQL Server based?
I would say it's all SQL Server based, but as far as databases go, yeah, it's all SQL Server.
Yeah, fantastic. And please follow Grant on Twitter at gfritchey if you're on Twitter. You can email me directly, james.merter@red-gate.com. Again, if you're on Twitter, please follow me at allthingsoracle. As I mentioned at the beginning of the webinar, I'm now going to do a live demonstration of one of our Oracle tools, which fits into the deployment suite for Oracle. So if you're interested in seeing how Schema Compare for Oracle works, please do hang around. I know this discussion has gone on for quite a while, so the demonstration won't be that long, so 10-15 minutes, but at least it will give you a chance to check out Schema Compare for Oracle. So before I actually go on to that, I'd just like to say thank you again to Jonathan and to Grant.
That's great. I'm happy to have done it, and had a good time there. Thanks very much, Grant and James.
Yeah, thank you. I really appreciate it.
Thank you. And again, got some great feedback
about getting some answers into all those questions, and be interesting to see what Grant says about some of them as well.
Fantastic. Thank you both, and I'll be in contact with you also about the next session. I think today's discussion brought out some interesting topics and also the reaction from the audience, as always. I think it's fair to say that everybody would like another session like this. So thank you both again, and thank you to everybody that joined us for the discussion. If you're leaving us now and you want to sort of go over this discussion again, as I mentioned, it has been recorded. It will be available on the Redgate website, and I will email you details of exactly when it is live. If you're interested in seeing Schema Compare, please hang on. Please just give me a minute or so just to get things sorted my end. Okay, thank you for hanging on. I hope the discussion again was useful. Going to give you a quick demonstration of one of our Oracle tools that forms part of the deployment suite for Oracle. So the screen we're looking at now, hope you can all see it. I've just had to bring up my remote machine, so to a little bit of sort of moving around of screens and stuff, is Schema Compare for Oracle. I'm actually just going to bring up what we call the edit project screen, because I think it's useful at this stage to see exactly what we're looking at. So when you first run Schema Compare for Oracle, you get this screen here, which will enable you to connect to your database and to compare schemas in different environments. And if we look at the top of this dialog, it's clear that I'm going to be comparing one database with another database. So I filled in all my credentials. We can have a look at the schemas that are on each of these databases. So in this example, I'm comparing a development environment with a test environment. I'm actually comparing two different schemas that are on the same database, but you could be comparing different schemas on different databases, or indeed different versions of the same schema on different databases. So once we set up the comparison, the tool will run through and diff both environments and then bring up a result screen. And this is the screen that we're looking at now. Again, if we look at the top, we can see we're looking at our development environment, widget dev, and we're looking at our test environment. The nice thing about the tool is just how clear it is, how clearly it will show you the differences between these two schemas. So we can see at the top here we've got 5 objects that exist in both but are different. We've got 5 objects that only exist on the development side, so these are new things that the team's been working on. But for each object, we can scroll through them and look at exactly where they are different in the screen below. So we can look through the DDL for each object. So for this one here, I've highlighted a package, and there's a few differences with with the procedure here. We've got a table with some new columns, and then we've got a whole bunch of new objects, indexes, procedure, and a grant. Sorry, I was just checking the question panel. Please obviously do ask questions. I'll try and come to the questions at the end of the demonstration, just so not to keep stopping and starting. Okay, so what I want to do now, particularly with the objects that are different and also the new objects, is how do I get them from the development environment into the test environment? And I can actually use Schema Compare to do that as well. So I'm going to select all of the objects, we've looked through them, we've reviewed them, we know we want to migrate some of these changes. I'm going to bring up the deployment wizard. We've got two options here. We can deploy using Schema Compare for Oracle, or we can create a deployment script. Either way, the tool is going to generate the script for you. So I'm actually going to use the create a deployment script. I think this is quite a good representation of how a lot of people will be using it. Also, it's just a nice way to show you exactly the stages that we go through to create this script. So we've set up, we can open a script we want to in SQL Developer afterwards, or whichever IDE you're using. We'll click through here. The tool is clever enough to basically warn you about anything that may go wrong if you was to run this script in your IDE. So we've got a few potential deployment issues here. The tool has suggested some actions. You can choose whether you want to apply these or not. Again, at the moment we're just creating a deployment script. So we're not going to use the tool to actually update. We could use a tool to update it, but this is obviously a much safer way. And there we go. We can see that we've created, it's not a hugely complicated example, but when we've got quite a few lines here of fairly intricate SQL, and we can obviously review that. We can copy the script to a clipboard, we can save the script off, so again a great way to be able to share this with the rest of your team. And as much as the side-by-side diff is going to save you a huge amount of time and looking at what's exactly different between two environments, this here is a clear time saver over handwriting deployment scripts. We have a summary of what's actually going to happen if you'd rather read it in this format, and we also have some warnings as well. So a couple of things if we've got a table be rebuilt. One of the items in the reference column, or one of the widget references table, obviously change the number of characters, so there's possible data truncation there as well. We can obviously copy these warnings to the clipboard as well. From this point, we could open the script up in our own editor again, or we could copy and paste it. Okay, so I hope that was a kind of a nice quick overview of comparing two databases and then generating a deployment script to move those changes across. We're looking at Schema Compare 3, so this is the latest version of Schema Compare. We did a lot of work on improving the UI in terms of how the side-by-side diff works. This precisely tells you what's different. We also improved the performance. In fact, Jonathan Lewis was actually at Redgate last week to look at the work that we've done on our Schema Compare engine to make sure that the comparison is done extremely quickly. But I think one of the most exciting features that we've got is this ability to create a folder of creation scripts using the tool to create a folder of creation scripts. There is another option here, which is obviously creating a snapshot of your database. And for a lot of tools and for a lot of people, that was one way of keeping a record of what's changing and actually putting something into a source control system, into Subversion TFS, something like that. But we've gone one step further. We actually enable you to create a scripts folder. And what I mean by a script folder is exactly that. So we're looking here. So I've just set up a folder called database here. This is the database that we're looking at. This is the development schema that we're looking at. In here we have a folder with all of the individual SQL scripts for all of these objects, all of the creation scripts. As you can see by the little green tick, that all of these are in my source control system. So how do we do that? So if we wanted to create if we wanted to do this for the first time, we could just create a brand new folder. So let's just create a new folder, and we'll just call this demo. Okay, so we've got a warning here, this folder is empty, so I can now populate it with the scripts by running a comparison and deploying exactly as we did before. So let's just run this comparison. Obviously there's nothing in that folder, so it's saying we've got 10 objects that only exist on the database. Again, if we're looking at the top of the screen, we can see we're comparing a database. We've got this little folder icon here to indicate that we're comparing against a script folder. We run the deployment wizard again. We select on, write scripts to folder. We can recompare after the deployment as well. We can even create a snapshot if we want to have another way of recording what we're doing. Everything that we've seen before in terms of which file is going to be created or updated, summary and any warnings. And here we have, in this demo folder, we have all of the creation scripts from that database. So as you can imagine, it's very easy then, wanting to, using whichever subversion system that you have, to add this and then to check those changes in. Similarly, if we just go back to our edit project, we can find an existing folder of scripts and we can compare that as well. So this is one that I've created earlier. Okay, sorry. That's what I selected the wrong folder. Apologies. So this is what I wanted to show you. So we've got here 9 identical objects, but we have one object that's different, and we can see where that difference is. We can, again, looking at side-by-side diff view, there's actually a new column in the source control version. So that could be something that another team member they themselves have done some development on this particular table. They've checked those changes in. You've just got an update from the source control system. You're now comparing it against your database, and there is a difference. And obviously you can use schema compare to generate the script that you need to pull that change into your database. So I hope that was a good overview of what schema compare for Oracle can do for you, how it can help you firstly compare databases and compare schemas in different databases and different schemas within the same database, but also how you can use the tool to output the structure of your schema as a set of creation scripts, a set of creation files, and then put these under source control. We offer a fully functional 14-day trial, and you can download this at redgate.com/schema-compare-for-Oracle, or go to red-gate.com/Oracle. You'll see all of the Oracle development tools there, and please navigate to schema compare for Oracle. You can download a trial there. So we've got a logo at the bottom here, the deployment suite for Oracle. So schema compare for Oracle is one of the products within the deployment suite. It sits alongside data compare for Oracle, which works in a very similar way, but it's comparing table data, lookup, configuration data. We have a little tool called schema doc for Oracle, which you can use to output the structure of schema as a HTML file. Again, something you might want to keep for auditing purposes. And we're currently working on a new tool which is called Source Control for Oracle, which, as much as schema compare for Oracle enables you to create a folder of creation of scripts, Source Control for Oracle will let you see exactly who is making changes, when they're making changes, and provide you a much clearer overview of what's going on with your database and with your source control system. So it will provide the link between the database and your source control system. Obviously, all of this information you can find at red-gate.com/Oracle. Okay, so we've got a few questions here. If you do have any questions about Schema Compare, please do type them into the question panel. I'll be happy to go over any part of the product again if you'd like me to. Okay, so first question from Lassie, I hope I've pronounced your name correctly, and this is regarding that they're looking at a versioning tool for the Oracle database, and the question is whether the Redgate solution, whether that you can use that now. Absolutely. Let me just... So if you go to... What should I have to put in? The first part, internal, if you go to redgate.com/source-control-4-Oracle, you'll go to this page here. You can join the beta program, simply fill in the form here. Once you've joined the beta program, you'll get access to our beta release. If I just click on this screenshot, you can see sort of an idea of what the interface looks like. This is basically this is looking at the changes that you've made to your database, the changes that you want to check in. So we've got an overview of those, and then we're using the Schema Compare side-by-side diff view to show you what's different between your database, each object, and what's in source control. There are further screenshots on the site. When you actually join the beta program, you'll get access to further screenshots as well. And of course, you get to download the product and try that. There's also quite a nice graphic here of how we expect the tool to work. The tool's in beta at the moment. We're going to release sort of new features and functionality. We've got a number of people that we're working with on the beta program. Please do help us out. Your feedback is invaluable. And we hope to release the tool at the beginning of March. Obviously, you can start using it now, and it'd be great to hear what you think of it. But again, just go to /source-control for Oracle, go to the Redgate website. You can navigate through from the product menu as well. You can see source control for Oracle there, and all of the information is on our website. Question I think I've already answered about comparing data. You can't compare data with Schema Compare for Oracle. If you go to our website, please visit Data Compare for Oracle, and this tool will enable you to do that. It has a very familiar interface, as you can imagine, and works in exactly the same way. I can bring up a quick screenshot as well to show you exactly what that looks like. So we've got a number of tables here, and then we've got the data side by side again with highlighted differences. Question from Brian regarding snapshots. So snapshots are XML files, so this is the structure of the schema. So you can take a snapshot of the structure of the schema. Okay, a few more questions about the source control capabilities of the product. So the kind of export into or creating the creation scripts is something that we've added to Schema Compare, which does go some way to helping you source control your schemas, or an easy way to put your schemas under source control. I would highly recommend that you check out source control for Oracle, because this tool, the main purpose of this tool, as you can see from this screenshot, is to make checking in changes to source control, getting latest changes, getting changes that other members of your team have seen exactly who's making changes, if you're a release manager or a DBA. That's what this tool is all about. So please do visit our website and join the beta program. You'll find out more information about this product. A question from Gary about will Schema Compare generate the necessary script? So if I actually bring up Schema Compare. Okay, so these are all of the object types that are supported, that are currently supported by Schema Compare for Oracle, and it will generate a entire script to be able to migrate changes within these objects across. I think another way, I guess, to explain that is probably if you actually look at the creation script here. These are the parts of SQL that will be migrated across, and you can obviously look through each of the objects. Okay, a question from Chris. I know, Chris, that you think that has already been answered, but it's quite an interesting one because source control for Oracle is a new product for us. We're going to be releasing a version on March. I think there's a huge amount that we can do going forward with the product, particularly with the way that different source control systems work, and would be really great to hear your thoughts on what features and functionality you need from the tool. We've done obviously quite a lot of work. You might want to check out the video that we have on this page. We developed the product live, or sort of developed a prototype for the product live at an exhibition. This will give you quite a nice overview of the feedback that we got from people at the exhibition. For those of you in the Oracle space, you might recognise we worked with people like Karen Millsap, Dominic Del Molino, Jonathan Lewis was also at the exhibition, a number of other Oracle experts. They sat on stand, they took part in usability sessions, they gave us feedback about this new product. Okay, so hopefully I've answered all of your questions there. As I mentioned before, if you do have any further questions for me, please do get in touch either through the Redgate website, or you can contact me at james.mercer@redgate.com. Please follow me on Twitter at allthingsoracle. So thank you once again for everybody for taking part in the main discussion, joining Jonathan and Grant for the main discussion, and also for those of you who hang around. I hope the demonstration of Schema Compare was useful, and I'll be interested to receive your feedback. Thank you again, and I hope you'll have a nice day or a nice evening, depending on where you are. Thank you.